This video will demonstrate how spreadsheets can be used to create multiple numerical examples, so students can spot patterns in the numbers and build their understanding on this. You will see a teacher using spreadsheet software to investigate the sum of an arithmetic series.
So I've got a column here for the term numbers, and then I want to add on 2 each time. What formula can I put in cell B3 that will accomplish that?
B2 plus 2.
So B2 plus 2. If I fill this down, what will the 10th term be?
21.
Why?
Do 2 times 9 is 18, and then 18 plus 3.
Anybody got any other comments? Gervir?
You just add on 2 each time.
You just add on 2 each time. So you said multiply by 9. Why multiply by 9 to get the 10th term?
Because there's 9 steps in between.
There's 9 gaps to jump. Very good. Now if I change the first number to 5, how will the list change?
It will all increase by 2.
All the numbers will increase by 2? Yeah. Okay, if I change the rule to add 3, so what will the new 10th term be?
33, I guess.
Shall we try? 32.
The first term hasn't added an extra one on.
Ah, so we actually add on n minus 1. Can you describe to me how we get from 5 to 32?
It's the first term plus 9 times the difference.
Why is it 9 times the difference?
Because you need 10 times the difference, but you're not. The first term is already given, so you're only 9 terms later.
So can you give me a formula if the first term was A and the amount added on each time was D, how could we get to the nth term?
A plus D times n minus 1.
A plus D times n minus 1. Can you give me a start number and a number to add each time so that the 10th term is 48?
Use simultaneous equations?
Yes, potentially.
So who's got an answer they want me to test?
A could be 3 and then D could be 5.
Okay, so I'll put A in cell B2. Yep, well done. Is that the only answer?
D could be 6 and A could be minus 6.
Oh, negative numbers. Yep, well done. What I'm going to do is I'm going to add up the numbers in this list. Can you see any patterns in the list that might be useful for the total?
You add the first term and the last term, they make 24, and then if you add the second and the ninth and carry on going, all of those pairs equal 24.
So can you use these ideas to get a number for the sum?
And if the first term and the last term added equals the second term and the ninth term, then we can do the first term and the last term and just times that by half the number of terms.
Okay, we all reached a number for the sum. Mohammed?
120.
120. So let's check. Well done. 120. Gervir, I think you had a formula just in terms of the first and last terms.
We did n over 2 times by the first term plus the last term.
Well, I'm quite a good user of Excel. I was confident with the technology, which I think is a big barrier for teachers who don't feel like they're confident users of it. The idea of being able to change the initial term and the steps so easily certainly helped the students come to the right conclusions.
A lot of teachers are familiar with using technology for graphical work. Is there anything about seeing a numerical table that maybe adds something different to students' understanding?
So I would probably go from a numerical representation to a graphical representation. For example, if I was discussing where an equation has solutions, I would look at a table of values, but then I'd want to link that to a graph.
I notice you type the formulas in
Yes.
and actually ask the students what the formula is. Do you think that's important in helping students construct their understanding of what's going on there?
I think the one software package that students are actually going to use in their everyday lives will be Excel. So I'm very keen to make them familiar with the Excel language. And also it is quite intuitively algebraic as well.
The questioning you used was quite open in some of it. Why did you choose that as a questioning style, and what do you do to get the responses back? What do you get if you get a room full of silence, if you use an open question and nobody says anything?
I'll usually ask more and more questions until I get a response. I'll go back a bit and back a bit and back a bit.
I noticed you got them to generate different examples with the same final thing. Is that a technique you use often?
Oh, yes.
To
Yes.
help them generalise?
And also to see that a problem doesn't always have just one solution. They did tell me that problem had an infinite number of solutions, which was very good.
Yeah.